Hi, I'm Akash, and I'm here to show you my remote sensing project that I had to do for my course ENME 489 at the University of Maryland. I had to build my LiDAR sensor, which is this, which I'm going to explain later. First, I'm going to explain what LiDAR is. It's basically a light detection and ranging. It stands for light detection and ranging, and how it works is there's a laser pointer. It emits a beam onto a target, and precise time is recorded. And once the light hits the beam hits the target, time is recorded again, and we get our range measurement from the constant speed of light. From this range, we can calculate the x, y, and z coordinates of my target relative to the Raspberry Pi. My LiDAR sensor, this is the laser pointer, which emits the beam as I talked about earlier. This is the breadboard, which contains the IMU, the initial measurement unit. It gives you the angular orientation of the target. And this is the Arduino, which powers the breadboard, which is connected to my Raspberry Pi, which has a Pi camera, which dictates the field of view of my LiDAR sensor. And ultimately, my Raspberry Pi is being powered by the battery pack so that I can access the Raspberry Pi remotely, so that when I go out on campus, I can have it ready without using my laptop. I can just use my phone. So in this class, what we had is we had a series of homeworks in which we had to calibrate our sensor and eventually go out into the field with our field deployable sensor to map individual targets. And what one of the homework was for the Raspberry Pi camera to track an object, and which what I did was track a green object, track it as it was moving, so you could see the Raspberry Pi camera focusing on one particular object and ignoring everything in the background. This is my target, the fountain outside the math building. It was built in the 1960s, and why I picked this target was because it had some nice features like this, which I could see while I'm mapping my target. That, that, which is this thing, and that, because I can easily see the diameter changing once I'm mapping my target, once I finally process my data to MATLAB. And yeah, that's about it. And now I'm going to show you how I scan the target. So to map my target, what I do is I first, when I talk about, I wanted to see if my data is coming out right when I actually process it through MATLAB. So you see the thing on top and the rod from where the water is coming out. I first map that and see if my data is coming out right and my sensor is calibrated correctly. So to map the target, I turn on my laser beam. If you can see the green dot on the target, and slowly and gradually I move down, move about 2 inches, and then scan it again. I don't know if you can see the green light, and then similarly keep moving 2 inches about the diameter and keep scanning. So once I'm done mapping the top part, I move to the base and then move around the circumference, similarly about 2 inches, and keep scanning. And once I'm done with the base, I move on to the column, which is this part, and collect my data the same way I collected for the previous two things. previous to the base and the top part. This is the MATLAB code in which I imported my text file that I got from my data when I scanned my target. It consists of the x, y, x angle, y angle, z angle from the IMU, and x and y for my sensor, which is the range measurement. Here you can see because when I was scanning my target, I got some random values because there were times when the camera couldn't see my laser. So here I filter out those values so that I only save in the values in which it's actually importing my target. And once I run it, I am able to see kind of a shape of my target. If you can see here, a 3D point cloud. Here you can see the change in diameter. Similarly here, the diameter initially, the big box that the first thing that I scanned, this is the shape of that. And similarly all my other plots related to the y angle, z angle, x, y, and z. And this is where you can actually see the target coming together. The column you can see is here, the base showing here, and then I couldn't get a proper view of the the box and the rod on the top, but it kind of shows my target. So after doing this project, I realized that there were a few shortcomings. First was that I realized that the target could have been too big for my project. That I had to like map 3 different things individually and moving in a circumferential manner, which could have induced errors into my data. And second was I thought that the laser pointer was a little weak, that my Raspberry Pi wasn't able to detect the laser even if it was on the target. And so we could have I could have used multiple lasers and shot and emitted several beams at once. And the third one could have been that the Raspberry Pi wasn't quick enough to measure the change. Raspberry Pi wasn't quick enough to realize that I was moving my sensor, so there was a little drag in the camera. So I had to wait a little bit and wait for it to get stable, so it could see the laser pointer. Otherwise, I learned a lot about LiDAR, and I definitely think that this is an emerging technology.